Welcome back to Bugs, Buzz, and Beyond, the show where we explore the amazing, the strange, and the downright unbelievable secrets of the insect world. Today, we're diving into something that sounds straight out of science fiction. How dragonfly wings can actually kill bacteria. Naturally. That's right. These shimmering wings aren't just pretty, they're powerful. And later in the episode, we'll have a short trivia time segment with 3 fun questions to test how much you've learned. Our topic for today is how dragonfly wings kill bacteria naturally. Dragonflies are among the oldest insects on Earth. Fossil evidence suggests they've been flying around for more than 300 million years, even before the dinosaurs ruled the land. They're expert hunters, lightning-fast flyers, and acrobats of the sky. But what's hiding on their wings is a microscopic secret that scientists only recently discovered. And it could change how we design future medical tools, like antibacterial surfaces or surgical implants. When you look at a dragonfly wing under a powerful microscope, you won't see smooth glass-like surfaces. Instead, you'll find a forest of tiny, nanoscale spikes called nanopillars. These nanopillars are incredibly small, about 1,000 times thinner than a human hair. And it's these spikes that make dragonfly wings one of nature's most lethal antibacterial weapons. Here's how the killing happens, and it's surprisingly brutal. When a bacterium lands on a dragonfly's wing, it's not welcome for long. The surface is covered with those sharp nanopillars, and as the bacteria settle down, their soft cell membranes get stretched and torn apart by the spikes. No chemicals, no poisons, just pure mechanical destruction. It's like the bacteria landed on a bed of nails. Only these nails are microscopic, and there's no escape. Within minutes, the bacterial cell walls rupture, and the microbe dies. This natural process is called mechanical bactericidal activity. It's one of the rare examples in nature where a structure, not a chemical, does the killing. Scientists first discovered this effect while studying cicada and dragonfly wings under scanning electron microscopes. They noticed dead bacterial cells clustered on the wing surfaces, sliced open as if by invisible blades. Now, you might be wondering, why should we care about what happens on a dragonfly's wings? Well, imagine this. Hospitals, surgical tools, or even water bottles coated with a material that mimics the texture of a dragonfly's wing. Surfaces that can naturally kill bacteria without chemicals or constant cleaning. In fact, engineers and materials scientists are now developing biomimetic surfaces, materials inspired by these wings. Using nanotechnology, they're trying to replicate the same microscopic structure in metals, plastics, and glass. These could one day help prevent infections, especially from antibiotic-resistant bacteria. which are becoming a major global health threat. Nature has always been the ultimate engineer. The dragonfly's wings were never designed with antibacterial warfare in mind. It's just a lucky evolutionary bonus. The wings evolved mainly for flight, but their microtexture turned out to have another superpower. And this discovery reminds us, even in the smallest details of nature, there are solutions to some of our biggest problems, if we look closely enough. All right, let's see how much you learned. Here are 3 trivia questions. Ready? Let's get started. Question 1. What is the main reason dragonfly wings can kill bacteria? A. They produce a natural antibiotic. B. Their surface is coated in toxic oil. C. They have nanoscale spikes that tear bacteria apart. D. They emit ultraviolet light. Correct answer. C. They have nanoscale spikes that tear bacteria apart. The dragonfly's wings are covered with tiny spikes called nanopillars. When bacteria land on the wings, their soft membranes get stretched and ruptured by these sharp structures. Unlike antibiotics that rely on chemicals, this is a purely mechanical process, meaning bacteria can't easily develop resistance to it. This discovery has huge implications for developing long-lasting antibacterial materials in medicine and technology. Question 2. How small are the nanopillars on a dragonfly's wing? A. About the width of a human hair. B. About 1,000 times thinner than a human hair. C. About the size of a grain of sand. D. The same size as a red blood cell. Correct answer. B. About 1,000 times thinner than a human hair. These nanopillars are so tiny that they can't be seen without an electron microscope. Their dimensions are measured in nanometers, which is 1/1000th of a meter. Because they're so fine, they can interact directly with bacteria at the cellular level, poking, stretching, and eventually rupturing their membranes. Last question. What field of science is using dragonfly wings as inspiration to design antibacterial materials? A. Astronomy. B. Nanotechnology. C. Zoology. D. Psychology. Correct answer. B. Nanotechnology. Nanotechnology involves creating and manipulating materials on the atomic or molecular scale. Scientists are mimicking the structure of dragonfly wings to develop biomimetic surfaces, artificial materials that copy nature's antibacterial design. These could lead to hospital surfaces or implants that naturally resist bacterial growth, reducing infections and the need for harsh chemical disinfectants. And that wraps up today's episode of Bugs, Buzz, and Beyond, where even a dragonfly's wing can teach us how to outsmart bacteria. If you enjoy this video, please check out our other bingeable channels. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution.